In case you didn't remember or you have forgotten, your final exam is in 1 week. 1 week from today. Okay? 1 week from today. If you can't make your assigned final period, go to the other one. Okay? No need. If you can't make either one of those, then we need to know about it. Okay? So if you can't make one, go to the other. If you can't make them both, then I need, or Mrs. Hill or Mr. Schmeling needs to know. Okay? Alright? Here we go. I'll give you... Good, there's only 3 of them. I'll give you a minute. Go for it. Tangent, looking right side, unit circle. Want tangent to be negative square root of 3. That's going to be down here at 5 pi over 3. Except the downfall is I can't use 5 pi over 3. So I have to say that that is negative pi over 3. It's got to be in that negative pi over 2 to pi over 2 non-inclusive, you might say exclusive range. Inverse cosine, look at top half, where on the top half is cosine negative 1, that is at pi. Agree? Okay. Arc sine of negative 1/2, again looking right half of the circle, where is sine negative 1/2. I want to say 11 pi over 6, but that doesn't fit in that range, so I'm going to go with negative pi over 6. Questions, comments, concerns, clarifications? Seeing or hearing none, let's jump into composition of trig functions with inverses. Now, a composition means that you're going to have multiple trig functions going on here. Okay? One of them is going to be an inverse. Now, the inverse could come first, the inverse could come second, could come inside, outside, doesn't matter. Okay? Either way, they're all done in the exact same way. We start on the inside. So we first start inside. Start inside, work out. So what I'm really looking at here is I'm looking at arc cosine of 1/2. What is arc cosine of 1/2? Pi over 3, do we agree with pi over 3? Top half unit circle, whereas x 1/2 happens at pi over 3. Yep. Okay. So that's pi over 3. So then, now, I have the sine of pi over 3. Because arc cosine 1/2 is pi over 3, so now I just have sine of pi over 3. Well, now I go to pi over 3. What's the sine value at pi over 3? Square root of 3 over 2. So my answer here is square root 3 over 2. The kicker is on compositions, you start in the middle or inside and work your way up. So again, we would start inside. Inverse sine of negative root 3 over 2. What do you think, Rach?
5 over 3?
Do I like it?
No.
Why not?
Because it's not in the range.
Yep.
Negative pi over 3.
Love that one even more. Yep. And what is the cosine at negative pi over 3? 1/2. Yep, exactly. For now. Good, KK? Great. Let's serious. You good? Yeah, okay. Yeah. It's right now, it's not that bad. Because we're all in the unit circle and we're all being nice. We're gonna get off the unit circle here in a little bit, and then it's not gonna be nice. Just wanted to make your day. Try those two. Agreed. Should have I only given you 15 seconds to do those two problems? Why? Because we've got a function and its inverse. They cancel each other out. We've got a function and its inverse. They cancel each other out. Okay? Right? No matter what order. We could have done inverse sine of pi over 2, and it would have been pi over 2. Okay? I think that's it for that page. So, just looking at number 5, what should it be? Pi over 3, right? Okay, let's check it. So the sine at pi over 3 is root 3 over 2. Yes? Okay. And then the inverse sine at root 3 over 2 is pi over 3. What do you want number 6 to be? You want it to be 5 pi over 3 because they should cancel each other out, right? But does 5 pi over 3 fit in my inverse sine range? No. So that's the one tweak is fourth quadrant angles with tangent and sine need to be negative angles. Okay? So this is sine 5 pi over 3 is negative root 3 over 2. Okay. Quadrant 4 angles are the ones that things don't necessarily work. Okay. Try those two. Good there. Cosine at 5 pi over 3. That's going to be 1/2. Inverse, oops. Not cosine of 1/2. Tap the brakes, Lens. Arc cosine. So I get pi over 3 there. Yes? Okay, because it's got to come back into those applicable ranges. All right, let's jump off the unit circle now. Okay. Okay, so let's think now. Where my question to you is, where is this? What quadrant? First quadrant, right? Okay. Cosine, your only choice is for cosine, because we're dealing with arc cosine. Your only two choices are first or second quadrant. So since it's positive, it's got to be in the first quadrant. So let's draw ourselves a little picture here, a little quadrant 1 triangle. Right? Cosine is what? Adjacent. So is that the horizontal or is that the vertical? It's going to be the horizontal. And cosine's adjacent and hypotenuse. So that one's going to be 5 here. Right? Our angles are in standard position. So we're going to call that theta. Right? Okay? So arc cosine of 4/5 finds us that angle, correct? So we really just need to find here the sine of theta. What do I need in order to find the sine of theta? I need that opposite side. What is it? 3. 3, 4, 5 is a Pythagorean triple. So that side is 3. So what is the sine then of theta? 3/5. Yeah. Okay. I think that was it on this one. I don't think Schmel. Oh, he did. So again, I ask myself, what quadrant is this in? Still in the first one? Okay. So it's still in the first quadrant. Sine is opposite over hypotenuse. There's my theta. So we want the cosine of theta. And what's the cosine of theta going to be? 12/13. Again, I ask the question, where is that one? Which quadrant is that one in now? The quadrant 2. Okay. So now I'm going to make myself a quadrant 2. Cosine is adjacent over hypotenuse. Actual theta is there, but I can use my reference angle. So I want here the tangent of theta prime, which is the same as the tangent of theta. What's the missing side line? 15, 8, 15, 17. Pythagorean theorem if you didn't know that. Over what? -8. So -15/8. Questions, comments, concerns, clarifications? You try example 12. So then this is going to be the secant of theta or theta prime. Secant is going to be the reciprocal of the cosine or hypotenuse divided by adjacent. I get 13/12. Questions, comments, concerns, clarifications? Okay. Try those two. Sine at 7 pi over 6 is -1/2. So this is inverse secant of -1/2. Okay. Inverse secant is like the reciprocal of inverse cosine, right? Okay. Right? Where on the top half of the unit circle is cosine equal to -2. Top half unit circle, where is it equal to -2? Nowhere, right? Because what's cosine got to be in between? 1 and -1. Okay? Not possible, undefined, does not exist, empty set, all those things. Okay? We'll take them all. Okay? Cosecant of tangent of -5/12. Tangent, so that's going to be opposite over adjacent. What's my missing side? 13? So this is really the cosecant of theta prime. Cosecant is the reciprocal of sine. Okay, so sine would be -5/13. So the reciprocal of that would be -13/5. Questions, comments, concerns, clarifications? Yeah, we have like 2 more slides to go. We gotta get the algebraic ones in too. Yeah. cosine is going to be adjacent over hypotenuse. So I get 5 over the square root of 34. Now, again, so that we all hear it, I am okay with 5 over the square root of 34 here, because we are not on the unit circle. Okay? I would not be okay if for some way you could simplify the square root of 34. So let's say it ended up being the square root of 24 instead. I would not accept the square root of 24 because I would want it to be 2 square roots of 6. Okay? Cotangent then is going to be adjacent over hypotenuse, or excuse me, adjacent over opposite. So that would just be 3. Questions, comments, concerns, clarification? All right. So now we're going to get into some algebraic type ones. I'm sure there's one down there for you to do. Okay. All right. We are going to make the assumption that all of the algebraic ones, because I don't think we ever give you a negative algebraic one. We're going to make the assumption that all of your algebraic ones are in quadrant number 1. Okay? So with that being said then, cosine in quadrant number 1 is what again? Cosine is what again? SOHCAHTOA? Cosine is adjacent over hypotenuse, correct? Okay. So this is really the sine of the arc cosine of three x over 1. Agree with that? So that means my adjacent side is 3x and my hypotenuse is 1. Which means I've got to run a Pythagorean theorem, and I got 1 squared is equal to quantity 3x squared plus b squared. 1 squared is 1. Quantity 3x squared. 9x squared. So this is 1 equals 9x squared plus b squared. I need to solve for b. What do I do next? Subtract 9x squared. I need to solve for b. Square root. One minus 9x squared. Square rooted is that 1 minus 3x. Or is it this? It's this, right? Yep. Okay. It's just this. Okay. So then now really, here is my theta. So I am finding now the sine of theta. Sine of theta is opposite over hypotenuse, correct? My opposite side is square root of 1 minus 9x squared. My hypotenuse is 1, so I can just leave it like this. Questions, comments, concerns, clarifications? You try that one. So sine is opposite over hypotenuse. We want the cosine then of theta. So the cosine then of theta is going to be questions, comments, concerns, clarifications. Entrance ticket for tomorrow are those 3 problems. Your homework for tonight, your entrance ticket for tomorrow.